Alright guys, we're at the lathe. Next job is to make some spacers to go behind the aluminium section that's going to go on behind the scale on the x-axis for the mill. I've got some stock here. It's mild steel, EM1A. It's about 42mm diameter roughly. That's fine. I'm not going to bother with doing anything with the OD, so we're going to chuck that up, make a couple of spacers, and what I shall do as part of that is cover a topic that's been covered several times recently around the use of centre drills versus the use of spot drills. And on a centre lathe, centre drills are designed for when you're turning between centres, or whether you're going to use a revolving centre in the tailstock. The 60-degree cone that goes in there, that you will put in each end of the part or in one end of the part, is deliberately 60 degrees so that you get a good mating surface with the cone of either the revolving centre or fixed centres if you're turning between centres. And what people often tend to do is use a centre drill on the lathe to go in pre a drill, and then you've got a 60-degree cone versus a 120-degree point, and you'll often see it on people's YouTube channels where they're following that with a drill, and you'll see the drill start wandering and there's all sorts of noise in the comments about your tailstock's offline and it's off centre, I saw it move, and the reason for that is it's not designed, a centre drill is not designed to be used that way. That said, a centre drill can effectively be used pre a drill as long as, and this is what I was taught in my apprenticeship, you don't go deep enough that you get onto the 60-degree cone, so you just use the parallel section of the centre drill to put the small hole in, and that almost acts as a pilot hole, and you can then follow that down with the drill as long as the drill is not 3 times or greater the diameter of the centre drill pit. That's a perfectly acceptable way of using a centre drill, and centre drills are really good for getting an accurate centre, as are spot drills. So I've covered it in talking. I'll probably cover it a little bit, and I don't know whether I'll use a centre drill or a spot drill this time around, it really doesn't matter, but I'll use one of them and we'll just talk about it a bit more at that point. So we'll get this bit of stock chucked up and we'll start getting ready to turn these spacers up. So I've got 2 spacers to make at 40mm, sorry, at 20mm. So there's plenty there. So I'll move the camera and bring you in and we'll start the turning. So for a change, I've used a spot drill in the lathe, which is really unusual for me. Normally it's a centre drill, but I've used a spot drill. I've put a bigger sort of spot than I would normally put in, and we're going to use, well, I need a hole through the centre of this that's clearance on an M8. So I'm just going to go straight in with an 8.5 drill, and we'll see how well that spot face copes with that. This is only mild steel, so it doesn't need a pilot hole really for that size. So we'll give that a go and see how we get on. I don't know if you noticed at the start of that hole there was no wobbling at all, the drill just went straight in. I know my tailstock's in line anyway because I've checked it, but you can see the difference there between if I'd have centre drilled and gone too deep and I'd got the 60-degree cone and done the same thing, that drill would have definitely wandered around at the start of the hole. So no issues at all using a spot drill. It's the proper way to do it really. Centre drills are okay if they're used properly. They've got their purpose and I explained that earlier. So yeah, just that's my take on it. Everybody's got their own. It's one of those topics that everybody's got an opinion on. That's what I was taught. It passes a straight face test for me and it's always worked okay, so that's kind of my take on it. Next job, we're going to chamfer. I'm just going to get a bit of emery cloth and clean. We've got a bit of surface rust on here, so we're just going to clean that off and then we'll start parting off my spacers. We've got the parting tool up. I'm just going to make sure that that's set square to the axis of the lathe, and I'm just going to use the front of the part that I've just faced off there now, because we know that that's can't be anything but square. So I need 20mm, and I'm going to go a bit further than that and leave myself a bit of facing stock for the other side. And the reason I'm doing that is I need both of these faces to be clean, and I need them to be a matched pair so that they're both exactly the same. So I could probably achieve it with a parting tool, but I want to take that risk away, and we're just going to leave enough stock on so I can turn them around, face them, and then we'll check them for, once I've done two, we'll put them on the surface table, set the clock up and just check that they're a matched pair both within a thou or so. That's good enough. So I'll just get my famous adjustable spanner, we'll lock the carriage off and we'll bring you back as we're parting off the first spacer. Right, we've got the parting tool set, we've got the carriage locked off. What I've done is brought the tailstock up. I've just got some brass tubing in there to catch the part when it parts off. That gives me two hands free so that I can use the coolant while I'm parting off. So we'll give this a go. We're going to run at 540 RPM and see how we get on. We're stuck a little way out the chuck, but we'll this will be the furthest out the chuck I've been with this. This is a 5mm wide parting tool, so it's not a slender one by any means. So we'll give this a go and see how it goes. Nicely done, no problem. So we're ready to part our second one off now. We just faced it up, chamfered the hole in the centre, set my 20mm again, or 21mm, ready to part the second one off. What I've done is move the camera a lot closer in, try and get a better shot of the actual machining of the parting off, and we're going to try this one a bit faster. We're going to try 800 RPM and just see how we get on. And that's more akin to what a CNC machine would be running at on this type of material. So I'm pleased with that. The lathe's really working well. That's a good test of a lathe. I know it's only mild steel, but it's a 5mm wide cut. That's a really good test. So pleased with that. That's got both of those done. We'll get them whipped round and we'll start facing them to length. I'll show you a little bit of that, and then I'll show you me checking them as a matched pair on the surface table. Right guys, we're just going to finish these off to length. So what I've done is I've got a parallel. We're just going to stick that in. I've cleaned the face of the chuck, I've cleaned the parallel, I've cleaned the part, and I've cleaned the chuck jaws, so everything's nice and clean. I'm just going to sit that parallel in there. Hopefully I grip the part before I grip the parallel. We're just going to use the parallel for setting. And then we're just going to face this face off. We'll take some material off, we'll give it a quick measure, and then we'll finish that to finish size, and then I'll pop the other one in and hopefully work to the same zeros, and that will be a matched pair, and we'll check that out on the surface plate when we're done. So I've locked my carriage off. I'm just going to use the compound slide to work to my finished size, so we'll just get rid of this leftover from the parting off, and then we'll take a facing cut. I don't know whether I'll be able to get my vernier in here or not. Probably not actually. Oh no, I can. That'll do. We'll use the vernier. A 0.95 stock to come off. Yep, 20mm on the nose. I'll chamfer them both afterwards because I don't want to lose my settings here. So we'll take that one out now. Just give everything a bit of a clean up again. And we'll set the next one up. In exactly the same way. Yep, 20mm on the nose. Before we start measuring these on the surface table, I'm just going to do the brake edging. Okay, so we're at the surface plate, so I've set the clock up on the clock stand somewhere near. We'll clean the plate off, we've made sure everything's clean. So we'll bring the first one up, we'll set a 0. And this clock's graduated in 1/2 of a tenth divisions, so sweeping around the part there with about 1/10 of a thou of parallelism and probably 1/2 of a tenth dish towards the centre. We'll bring the second one in. There's probably slightly more parallelism, probably 2/10 parallelism, and it's nominally about 1/10 of a thou thicker than the first one. And I think 1/10 of a thou over 700 millimeters supporting the DRO scale on the x-axis will be perfectly acceptable. So we'll move back to the mill now. Oh no, we won't, sorry, apologies, we're going to stay at the lathe. We've got 2 more spaces to make a little bit like this that are going to be used as clamp plates on the front of the aluminium backing piece, and that'll become evident as I work through it. So I'm going to use some of the same bar, pretty much identical to this, but 15mm width with a counter bore for the cap head screw. So I'll go back to the lathe now and do that. So I've reloaded the bar end back up in the chuck. I'm not going to mess around with these so much because these don't matter parallelism wise and surface finish wise so much in terms of being accurate or being a matched pair. So I'm just going to carry on with the chamfer tool that's in there already. We're just going to clean this face up to make sure it's square, chamfer it. We'll carry on with the drill and we'll poke the drill down probably all the way through this block, and then we'll part it off at the right thickness. Oh, and I've got a counter bore to put in as well, so we'll counter bore it and then part it off. So I've got a 14mm end mill. I don't really like using end mills in the lathe, but we'll give this a go, just see how it cuts. It's a fairly new end mill. We need to go 8mm deep, which is 0.315. So I'm just going to set that to 0. We're just touching on there. This is imperial, so I need to remember that this time and not go too deep. We will run at 260 and see how we get on. Remarkably well behaved. Yep, that's good. So we just need to deburr that now with the countersink. So I'll just get set up with the parting off tool and we'll part that off. So I've set this just with a rule. That's perfectly good enough for what I'm doing, and I might just give a tiny skim on the back when I chamfer it just to make sure it's cleaned up. Really unimportant. You'll see when I come to the build what it's doing. Like a knife through butter. There we go, that's finished both of those two off. I just flipped them round, both of them, gave them a quick face up on the back, and obviously countersunk the central hole. So the idea behind that, so these are the first spacers, the ones that I needed to be accurate across the width. Basically what's going to happen, excuse me while I just keep reaching around for things. So right at the front of what I'm doing will be this spacer, washer, whatever you want to call it, the cap screw going in there. In between that will be the aluminium backing plate that's going to hold the scale, and then behind the aluminium backing plate will be this second piece. So basically I'm going to trap the aluminium backing plate between these two spacers, and then obviously right in the very back in the T-slot will be the T-nuts that I've made, and basically that's how I'm going to support the scale on the mill. So next job now is to give all four of these a good degrease and the T-nuts and get them all chemically blacked, just to give them some corrosion protection really. I'm not too worried about the aesthetics, I just want to try and keep the rust down. So everything else that I've chemically blacked in here seems to be standing up quite well to the moisture, so the mild steel, we'll drop them in, chemically black them all. I've shown so many videos of mine, I've shown that chemical black process, so I'll just do them all and show you them when I've got them all complete. There we go guys, that's got my chemical blacking done now on all 6 pieces, so they're now ready for fit into the machine when I get the aluminium piece complete and we get the scale fitted to the machine, or the backing plate, sorry, fitted to the machine. That's when these will all come into play. So next job now is to move on to the backing plate and get the holes put in that in the right place for all of this to interface with it, and I'll bring you back when we're doing some of that.